Hey everyone, I'm Matt, engineer at Uber, maintainer of Store, and going to be talking about a paging solution that we've been working on for the past couple, maybe like it's been a long time actually, like a few, like half a year. Yeah, and I honestly I didn't think this talk was going to happen like. Maybe like 2 months ago. I was laying in bed and thinking like, what did I sign myself up for? This is really hard. And a couple nights later, I was watching YouTube videos, and this guy that everyone here knows said the use cases are really only limited by your imagination. And I thought, like, I wonder if it can solve my problem. StoreX paging. It's a UDF first design. We have a new concept of a self-updating item. There's operation pipelines for data transformation, so like things like filtering, deduplication, validation, support for local and remote mutations. We're using Store under the hood. Tons of customization points, so things like launch effects, things that you want to do as soon as the pager initializes. Middleware, things that you want to like apply to the params, side effects after you have a snapshot, eager loading strategies, fetching strategies, error handling strategies. Something that I'm like personally excited about, it's all compatible with Android X. So our builder can just take in a paging source, and then we can like add all of these other features. All major Kotlin targets, and then it's powered by Compose, Molecule, and Store. All right, so performance was top of mind throughout this. Like, what we wanted to do is we wanted these self-updating items that, like if you have this like paging list, and you like a post, for example, we wanted that to be live. We didn't want the whole list to have to update. We just wanted that single item to update. And so we had all of these like item level models that we were managing, concerned about performance. So we did a bunch of benchmarking. Initial load time, Android X. I was like super happy about this. I was really excited to see this. We're only slightly slower. Incremental load time, we were a little bit better, but I mean, these are so close. Memory utilization, Android X is better. Recompositions though, this is like where we win, is because we have these self-updating items that I'll get into. And then janky frame delays did slightly better there. All right, so powered by, so Store. There's links here that I'll share in the slide deck later. But we have this talk with myself, Mike, and Yeet. Then Mike and myself gave a talk here last year about Store 5. And Yeet and Mike gave a talk at Kotlin Conf about Store 4. Then obviously we're using Android X stuff. We're using the Compose runtime, which I'll get into. Yeah, and so that like little story I mentioned, the guy was Jake Wharton, and his quote was about Molecule. The Compose runtime, it's really, really great for managing a tree of nodes of any type, and it doesn't need to be UI related. Compose doesn't care. All right, so Molecule. There's tons of talks, there's tons of resources online. I'm not going to go into it too much, but the essence, and this is from the YouTube video I mentioned, taking the Compose engine, turning it on, having it emit new values into a state flow for consumption. Compose handles recording values, and if it decides your function needs to be recomposed, it handles recomposing and emitting the value. And the quote that got me to try this was right there. The use cases are really only limited by your imagination. All right, so, and there's a bunch of talks on Molecule. So UDF first. So I really, really like Circuit. Like all of my sample stuff is using Circuit. I love it. So UDF first was a big design principle. So paging has this open ticket for supporting UDF. If you've used Pager 3, it's this like paging data and paging items, and it's hard to work with at the presenter level. So that was kind of a big thing, and I'm not going to go into the details here. I think everyone knows the benefits of UDF, but separation of concerns, testability, reusability, scalability. All right, so our pager, this is kind of pseudocode. There's more generics and there's more methods, but the core method is getting the state flow of paging state. And so this allows your presenter to just collect the paging state, right? And then it can emit it to the UI without a flow breaking stability of the compose. And it's just a state flow of paging state. It's really clean, it's really nice. So paging state, what is it? This list of IDs and load states, combined paging load states I took from the Android X solution. And you'll notice here that it's a list of IDs rather than a list of values. So our solution is normalized. We're not passing the values down, and that's what allows the self-updating item to work, is the self-updating item just takes in an ID, and then it's like a little molecule for the item. So the example presenter here, it's just taking in the pager, you can inject it, collecting the paging state, and then if you're familiar with Circuit, it's emitting the state with an event sync, and the event sync can, in this case, like on a refresh event, it's just refreshing the pager. So it's very, very like clean, very, very nice. So self-updating items, I've mentioned that a few times. So I took the name from this issue on Google. Self-updating paging results. The thing is that like paging expects, like it said, like I've underlined here, expects immutable, gradually loading snapshots to be returned from paging source. And so like anytime there's an update, the whole thing is updated, right? And so like if we have this list of things, how can we only update the item? So that's what we were trying to solve for. So self-updating item, it makes item level state management possible. So each item in the list has its own model. Whenever one of those items updates, the item updates, the list doesn't update. So the API for this, this looks like molecule, right? So it presents the item state, it takes in an event, that can be a refresh event, it can be an update event, it can be a clear event. And then we have this self-updating items list API. And that is taking the IDs from the paging state. It has like a pull to refresh that we just baked in. And then the user is just passing in this composable that takes in a model, the content parameter. And you'll see that here. An example of the content is it's taking in the model, and then it's just, like if the item is null, then it's showing the loading skeleton. If we have data, then showing the data. It can be more fine-grained than that. So we have all of these states. So like if it's initial, if it's loading, it can show loading. If it's fully loaded, we can show the data. If it's refreshing, we can show the data and a refreshing indicator. If we have data and there was an error, we can show a certain UI and so on. So all of the state is provided and made available to the user, but it's not, like you can just do it really simply if you want to. The list content, like this is the view model or the presenter is emitting the state, which is a list of IDs, and then it's providing it to this lazy self-updating items composable that we provide. And that's all you have to do. All right, so operation pipelines. I set out with the intention of solving for sorting and filtering and all of these other operations, and sorting is like super hard and it doesn't really make sense. So I just wanted to like highlight that here. There are some use cases where it might make sense, like a Reddit app, for example, where you have like best or top or new, and then you're like filtering and then you're sorting. And you know for sure that like every subsequent fetch is going to be in the right order. But if it's like, I don't know, like a feed that's constantly updating and the post could be like bubbling up, right, then it's super hard. But this Google issue, the point is like, so imagine you have a feed, right, and you're scrolling down, and it's supposed to be sorting the best, right? And you fetch a new thing from server, and it sends down this new item that's at the top of the list. It would be super confusing for the user to see like items disappearing and appearing, and like scrolling back, and you're being like gaslit by your UI because you can't see like where did that thing I was looking at go. And so that's like the core of this issue. And so we make it possible to sort, but I also agree with this that you probably shouldn't. So the operation API, it's an abstract class. It takes in, we provide a snapshot. Every time we fetch data, every time the data updates, we take a snapshot and we make it available to the developer. And so then they can apply these operations, right? So it can be like, I don't know, like, do I want to filter? Do I want to validate certain data? Do I want to deduplicate data? And so you'll notice that it takes in a paging state, which I already showed, and the fetching state. So the fetching state API, right, like we're tracking all of this stuff. So every time a scroll happens, we're updating the minimum item accessed, the maximum item accessed. We're tracking the minimum requests, the maximum requests, tracking the minimum item loaded, the maximum item loaded, and then we're tracking the prefetch offsets, both forward and backwards. So like a real world use case, I mentioned Reddit. So they have this like you can get the best post, you can get the hot post, the top post, the new post, right? So like if we look at the top posts, let's say this is our data model, and we have, it has like an ID, it has, is retweeted by the viewer, is liked by the viewer, the relevance score, the trending score. And then we have these like time ranges, right? An hour, a day, a week, a month, a year, or all time. So our operation for sorting for time range, like you take in this snapshot and then it's just filtering, like is it within this range, and then sorted by descending. And then this is applied at the presenter level. It's like not in the UI. We're not mapping on paging items. It's in the UI. It's testable, separated. Sorting method. This is just an example of like what you could do, right? You could have like a new sorting method, a best sorting method, top. And then the presenter, this is a circuit presenter. It's collecting the paging state. It's keeping track of the sorting method, right? So like if the UI sends up an event that the sorting method changed, we update it here. Every time it updates, then we pass that to the pager, and the pager updates the certain, the list at that point. And then we have a paging event sync. And so we can look in more detail. So when the sorting operation changes, we have this launched effect. We update the sorting operation, and then we update the pager operations. And so every time the pager operations are updated, then we are actually like changing the list of items. And again, like here, the user has a lot of control at the presenter level rather than the UI level. So here we're just switching on the event and updating the sorting method when it's like, the user tapped on sort by best. All right, so mutations. So last year, Mike and I talked about store 5. The big thing then was store, mutable store, which was like offline support for store. So this introduces like a new type of store. It's a normalized store, which I mentioned before. And so a normalized store is like, we have like a list, right? And a list of IDs, and we're tracking the ordering of the IDs within the list, and then we're also we have like a map of the items. And so we're not storing a bunch of stuff, we're storing each thing once. And so this normalized store can get the self-updating item. It can load a page, it can invalidate the data by key or altogether. So this is kind of like pseudocode for our concurrent normalized store. I mean, this isn't telling you that much, but it's, I think one of the things here is that we are, like lines 21 through 22, item queries, this is SQL delays. So like we have our own, you can provide your own database, or you can just provide like a, bindings for us, but we keep track of the items and the pages, and so we can invalidate stuff. Page cache, this is kind of interesting. So here it's a linked, doubly linked list with hash maps, and we're just keeping track of references, right? And so it's a list of IDs, like I mentioned, and then every time the ordering of the IDs change, we update the item cache as well. Can skip this. All right, so another like real world use case is liking a post. So this is important for mutations, right? So like this is actually super simple with the solution. So like with this post, we have is liked by viewer. The UI here, like let's say we have a row, and we have it has like the image, it has the username, the text, content, hashtags, and then actions, right? So that's what this is. It has the row, the image, and then a column of stuff. So we're going to go into the actions. And all it does, like we make it possible for the model to be just, like how like a view model is, you can do like view model equals view models, and then it'll just be provided. We do that with the self-updating item. So you can get the model, and then if you want to update it, you can just update it, right? And we'll take care of all of the hard work of like updating the caches, updating the database, sending a network request if you want to. So that's all there is to that. Tons of customization points. Not sure if everyone's going to use these, but things like launch effects, which I mentioned before. So all you have to do with the bit builder, say you want to like initialize custom logging, or you want to hydrate the cache with certain data, totally possible. Middleware API, so we provide the params, and like every time we get a request, we go through this middleware pipeline. So like imagine if you want to add custom headers, you want to obfuscate certain data, also totally possible, super simple. Side effects, so every time we take a snapshot, we provide that to the developer and say like, if you want to do something with it, have at it. So like say you want to trigger some push notification when X, or trigger some push notification when Y, or like you have some other data source that you want to synchronize. Also super simple. Fetching strategy. So every time like you're like scrolling on a feed like down or up, right? Like we need to decide if we're going to fetch more data. So like should fetch forward, should fetch backward. So we provide a default fetching strategy that works, I think, in a lot of cases. But like, you're totally welcome to provide your own fetching strategy. So our default, like digging into it, it's first we need to determine the sort direction, right? Because like the feed could be sorted by any number of things. It could be ascending, it could be descending, you know, we could not know. So like if it's ascending, we perform certain calculations. If it's descending, we perform certain calculations. If it's unknown, we perform all of them just to be safe. This is the check fetch condition. I'll show you these slides if people want to look at the code, but I don't know that it's super valuable to go into it line by line right now. But the like at a high level, we're determining like how far have they gone, how far do they want to like prefetch, and are they within that limit or not? And then we make it possible to provide your own error handling. So like right now there are 3 strategies. Like you can ignore an error, you can pass it through to the UI, or you can keep retrying. So like if you ignore it, right, like we're updating our various queues and not doing anything because that's what the developer wants. If we're passing it through, then we're removing placeholders. We're emitting it to the UI, and we're updating our queues. The retry last is more interesting. So like, say you want to retry up to 3 times. We'll just keep track of the retry count and we'll keep going. Obviously, like we'll emit these states to, which you can keep track of in your presenter. So it's not swallowed or anything, but then we'll just keep trying and we'll eventually back off. All right, so this Android X to StoreX, it's our builder just takes in an Android X paging source, and then we map it to our own stuff. So all of the benchmarks I mentioned, it's with an Android X paging source so that we can just compare things. You can also provide a StoreX paging source. It doesn't really matter, but you do need to provide a paging source. And then we take that paging source, we provide it to the normalized store that I talked about, and that's it. I put these, yeah, I think that is all I have. Definitely happy to answer questions, or I'll be at the Uber booth for most of the day, so if people have thoughts or questions. We're aiming to, I think, release like an alpha of this over the summer at some point. Probably not too soon, but yeah, that's all I have.